When looking at a finite geometric series, all that finite means is that it's not infinite. But what a geometric series is the sum of a geometric sequence. So if I want to find that sum, which I'll call S sub n, that's going to be the first term plus the next term, which remember is the first term times r to the n minus 1. So this would be r to the first, plus the third term is a1 times r to the second. The fourth term is a1 times r to the third, and so on, all the way down to a1 times r to the n minus 1, which remember is the formula for every term in a geometric sequence. And all we're doing is adding all of them terms together. Now what I'm going to do is take that sum, and I'm going to multiply it all by r. Then that would give me a1 times r plus a1r times r is a1r squared, plus a1r squared times r is a1r cubed, and a1r cubed times r is a1r to the fourth, and so on, all the way down to a1 times r to the n minus 1 times r is a1 times r to the n. I want to do that because I want to subtract all of this. When I do that, on the left hand side I'll get this expression of Sn minus r times Sn. But on the right, look what happens. I mean, our first term is going to stay there. But here we'll have a1r minus a1r. a1r squared minus a1r squared. a1r cubed minus a1r cubed. And that'll happen all the way down until the only thing we're left with is minus a1r to the n. So on the right hand side, we're left with a1 and everything down to minus, this minus right here, a1r to the n. Now just doing a little math magic, we can factor out Sn, be left with 1 minus r, and then divide. So I'll have a1 minus a1 r to the n divided by 1 minus r. And this is going to be our formula that you should totally write down in your notes and refer to often for finding the sum of a finite geometric series. So let's try one. Here's a geometric series, 2, 6, 18, 54, 162. What we're doing is multiplying by 3 every time. So if I want to find the sum of all these terms, well, there are 5 terms there, so I'm finding S sub 5. And we just use our formula, a1 minus a1 r to the n over 1 minus r. So since we're finding the sum of 5 terms, we're going to start with our first term, minus our first term times the common ratio to the 5th power. Every time we were multiplying by 3, so that's our common ratio here. And we divide by 1 minus our common ratio, which is again 3. Now we have all the numbers in the formula, and it's just a matter of simplifying. So 3 to the 5th power is 243. And 1 minus 3 is negative 2. So 2 minus 2 times 243 is negative 484, which we're going to divide by negative 2, and we get 242. And if you went back up here and added all these up on your calculator, you should get 242. Let's try one that's written in sigma notation, where the index goes from 1 to 16 of 4 times 3 to the I minus 1. A very good first step is to write out a few of the terms. Like plugging 1 in there, we'll get 4 times 3 to the 0, which will just be 4 times 1, or 4. The next one, when we go up to 2, I equals 2, 2 times 1, 2 minus 1 is 1, 3 to the 1st power is 3, and 4 times 3 is 12. The next one, 4 times 3 squared is 36, and that's going to keep on going all the way down to the end, where we go 4 times 3 to the 16 minus 1. And the number that we get at the end is 5739562 Pretty big number. Okay? But what we do notice, the important thing is that as we go from term to term, we are multiplying by 3 every single time. So we are talking about a finite. It doesn't go on forever. It's finite. It's geometric because we're multiplying by the same term every time, and it's a series because we're finding the sum of it. So we find the sum of, this will be 16 terms because we're starting with the first term, ending with the 16th term. So that's 16 terms. So we go ahead and grab our formula, which is first term minus first term times common ratio to the 16th power. Here our common ratio is 3 over 1 minus 3. So you just go ahead and try and do this more in your calculator instead of breaking it all up. For instance, you could just type in the first line of the numerator, 4 minus 4 times 3 in parentheses to the 16th power, and you get a huge number, negative 1721868880, and divide it by 1 minus 3, which is negative 2. So just take that number, divide it by negative 2, and you'll get your sum of 8609340. That's 86 million. Which, does it sound reasonable? Look up here. Our very last number was 57 million, so we should end up with a sum that's bigger than that. And there we go. So the thing to remember about a finite geometric sum, or the sum of a finite geometric series, is that just the formula, first term minus the first term times r to the n over 1 minus r. Write it down, use it over and over again until you feel super comfortable with it.